So we learned about different greenhouse gases, namely carbon dioxide and methane, and we learned how humans are increasing them in the atmosphere, whether it's burning fossil fuels or having a whole bunch of cows. And we've been able to measure that change. We know we're increasing carbon dioxide, and we know carbon dioxide and methane are greenhouse gases. So what's happening? And the big topic is climate change. By changing our upper atmosphere, by changing that greenhouse effect, we are changing our climate. So one of the effects of increased GHGs or greenhouse gases is that we are seeing warmer temperatures. The average surface temperature across all of Earth is increasing. If you look at the past 17 years, so from 2000 to 2017, the past 17 years are the highest and hottest years on record, or I should say 16 of those 17 years are the hottest on record. The only one that's the exception is 2001. It was cooler and not on this top list. And 1998 is on that list instead. So you just switched out 2 years that were only a couple years apart. This list here is showing you these top 10 years. Or really top 12 because there's a tie for 10. Last year was the hottest year, and the year before was the second hottest year, and the year before that was the third hottest year. Over here, the anomaly in degrees Celsius is how different is it from the average temperature since we started measuring temperature. We started measuring temperature accurately starting in 1880. So this is looking at all years on record from 1880. We took the average between 1880 and 2016, and we're comparing these values to that average. 2017 is currently ranked as the second warmest year, but we won't know for sure where it falls on this list until the rest of the year, so we'll see. Now again, this is average temperature. Some places may be experiencing cooler weather, some places may be staying the same, but overall, more places are warming up than they are cooling down. This is interesting and should make sense because if carbon dioxide and methane are greenhouse gases, that would mean if there's more of them, then it'll be warmer. They hold in more heat. And scientists have been seeing that. So if you look back at those ice cores, scientists have ways to look at the temperature when that ice formed. They do it with a bunch of fancy analyses that if you're interested in, I'm more than happy to explain to you. But just know that they do know how to measure temperature given those ice cores. And if you look here, temperature and carbon dioxide match each other pretty well. When you're seeing carbon dioxide go up, you see temperature go up. If you're seeing carbon dioxide go down, you're seeing temperature go down. It's not perfect. For example, here we see temperature go down first and then carbon dioxide. So we don't know if there's a clear cause and effect relationship. But it is pretty interesting how well they match up. The question is here we are, this was 10 years ago, so we're really actually up here at 410. The question is temperature going to follow us? I don't know, and we'll see. This is kind of the concern is, oh, we're increasing carbon dioxide a lot. Does that mean our temperature is going to increase a lot? It has been a little bit, so we'll find out really in the decades to come. Because of this increased temperature, this is changing our weather patterns. And you've probably seen this change in weather patterns. One, we have both more drought and more rain, which kind of sounds counterintuitive. Essentially, places that typically get droughts, thinking about deserts and other places along the desert line, those places are going to continue being dry but get even drier. And surrounding areas, even here in the United States, such as California, so areas that are typically dry are only going to get drier. However, areas that get rain are going to get more rain. Essentially what's happening is the reason we have rainforests is because the rain and water that would typically go to a desert doesn't. Due to different airflows, that rain instead gets transported to other areas such as our rainforests. So what's going to happen is that's going to get accelerated. More water is going to be taken out of those dry areas and dumped on those wet areas. This is incredibly important for agriculture. Our crops usually have to grow in a very narrow range of not only temperature, but of water, of precipitation. So this is really going to affect the global food supply. The other thing that warmer weather can do especially is affect hurricanes. There's a lot of different types of storms around the world, but hurricanes are fueled by warm air and warm water. By increasing air temperature, increasing warm water, we're increasing the severity. So how severe, how much damage do these hurricanes do, as well as the frequency. So having more and more frequent hurricanes. In 2017, we had a couple huge storms that decimated particularly island nations in Central America, as well as affecting quite a few states here in the United States. We can expect to see even more of that. Related to these warming temperatures, we're also seeing melting sea ice. There's a couple different ice packs to think of though. The first one are glaciers. You may have heard of glaciers before. Here's an example in 1928 of a glacier. Glaciers are essentially compacted ice and snow. And glaciers are remnants of our last ice age. Our last ice age, about a third of the Earth was covered in ice and snow, starting from the Arctic and kind of moving down. Glaciers are remnants of that. This is snow and ice that just hasn't melted from the last ice age. That's why you only find glaciers further north. It's been cool enough further north to maintain that glacier for the past 10,000 years. 10,000 years that snow and ice has been around. But in our lifetime, those glaciers are melting. This picture is showing you the disparity between 1928 and 2004. In 1928, and the past 10,000 years, this glacier has remained here. But over a span of 80 years, it has completely melted away. Now it's kind of cool. I mean, you see this new ecosystem. There will be animals and plants that colonize it. So it's not so much that the glacier is gone and that's harming the environment. If anything, making more environment. The problem, though, is that this is a warning to us, saying, oh, it must be getting warmer because this ice that's been here for 10,000 years is now gone. So it's a warning to us. Also, that water had to go somewhere. Some of it is here in this lake, and eventually whatever was left over is going to go into a river, into a river, into a river, into the ocean. And that's going to contribute to sea level rise, which we'll talk about in a moment. We have two poles on Earth. We have the Arctic and we have the Antarctic. And it's actually very interesting what's happening with those. The Arctic is melting. Here is two pictures comparing the Arctic sea ice in 1984 versus 2012, and it's only getting smaller. And you see such a huge difference in this ice cover. Whereas the Antarctic is growing, but not growing as much. So although the Arctic is losing a bunch of ice, the Antarctic isn't growing that much ice. We don't really know why the Antarctic is growing, but we understand why the Arctic is melting. In the Arctic, this is just ice floating. The Antarctic, though, there is land underneath that ice. So think of the Arctic as an ice cube, that if the water underneath that ice cube is getting warm, it's going to melt that ice faster. But with Antarctica, they have a landmass underneath, which is why Antarctica is not really melting, or at least not seeing drastic changes like we do in the Arctic. So there's a video presented by NASA that kind of explains this Arctic and Antarctic, and they talk about the sea ice a little bit. So go ahead and pause this video and watch the video that's popping up now to learn a little bit more about this phenomena and about how we measure it. Because we have sea ice melting, in the Arctic, it doesn't matter so much if ice is melting, and the reason for that is because it's an ice cube, When that ice cube melts, it's not going to cause your glass to overflow. It's just going to stay at the same exact level. But with our glaciers melting, as well as water getting warmer, as water gets warmer, it expands, we're seeing an increase in our sea level. In the past century, so the past 100 years, sea level has increased by about half a foot. And that doesn't sound like a lot, and it really isn't a lot. The problem, though, is if we continue in that trend. About 5 million people just in the United States, 5 million people live less than 4 feet above high tide. So we've already hit a half a foot. So if we only increase by the same amount, that would take, 700 years to raise to 4 feet? That's a long time, right? 700 years. But the question is what if it gets higher? What if it starts moving faster than a half a foot every century? And also, there's people who live, 8 foot above sea level. Where I lived growing up, I was about a foot above sea level. Actually, I think technically I was 8 inches above sea level. So my place, is close to drowning, right? So really, really important that, by increasing temperatures, that's actually having a cascading effect on our environment. And then finally, although there's tons of different things that happen, another big one is that animals are being affected. So for example, because it's warmer, insects are out longer. Insects in and of themselves aren't bad, but keep in mind that insects directly affect humans. Think about mosquitoes especially. The best day or the best reason fall is amazing is because there's no mosquitoes around. Mosquitoes carry diseases. They carry West Nile disease, they carry malaria, they carry yellow fever, they carry all sorts of things. Now we're saying that these mosquitoes are going to be around even longer, ticks even longer, fleas even longer. So they're emerging earlier in the year and they're staying longer in the year. Not only does this affect human health, but it's also affecting agriculture. Think about all those pesticides we talked about in class. Well, we need to be using even more pesticides because there's going to be more pests more times of the year. Another thing that will be affected by these insects is birds. Birds are one of the largest predators of insects in general. And different birds are being affected differently. Some are benefiting from this. Some are losing out of this. For example, our aerial insectivores. So these are birds that eat just insects. Their numbers are vastly declining because they're used to migrating based on the insects, but the insects are emerging earlier, and so these birds are missing out on that food source. Grassland birds, where tons of insects are found, also declining. Although they are declining, we do see other birds increasing for other reasons. So although you're like, well, yeah, we're losing some, but hey, we're gaining others, I don't disagree with you. But what we're seeing is huge changes in our ecosystem, which again is a warning to us that we are doing something that is affecting this ecosystem. Plus, this might be throwing things out of balance, which could cascade to organisms you and I consume, and then we do start seeing a difference.